In October 2017, astronomers noticed a tiny object racing through our solar system at an extraordinary speed. It wasn't orbiting the sun like the asteroids and comets we had spent centuries cataloging. Instead, it was simply passing through. It arrived from the vast, freezing darkness between the stars, made a sharp turn around our sun, and began disappearing back into the void. This was the first time humanity had ever confirmed an encounter with an object from interstellar space. But as telescopes around the world tracked its retreat, the data became increasingly difficult to reconcile. The object accelerated without an obvious physical cause, possessed a highly irregular shape, and displayed physical traits that contradicted our understanding of how comets and asteroids are supposed to behave. These anomalies turned Oumuamua into one of the most debated subjects in modern astronomy, leaving scientists to reconstruct the story of its origin from the few data points captured during its brief visit. The first evidence of this visitor came from the Pan-STARRS telescope in Hawaii on October 19, 2017. Perched on a dormant volcano, this instrument is designed to find near-Earth objects by identifying anything moving against the static background of the stars. In our corner of the galaxy, gravity is the master. Standard comets and asteroids are physically bound to the sun, traveling in closed, elliptical loops that they repeat over and over again. Oumuamua's speed told a different story. At nearly 196,000 miles per hour, it was moving far too fast for the sun's gravity to hold it. Its path wasn't a loop, it was an open-ended curve. This hyperbolic trajectory served as the mathematical proof of its origin. By tracing that path, astronomers confirmed that the object arrived from outside our solar system, crossed our inner orbits, and was now aimed toward the stars once again. This single observation confirmed that our solar system is not an isolated bubble, but is instead part of a much larger exchange of material moving through the interstellar void. Because Oumuamua was small and moving away rapidly, we couldn't photograph its surface directly. However, we could see that it was reddish and tumbling chaotically end over end through the vacuum. As it spun, its brightness fluctuated rhythmically, becoming 10 times brighter every few hours. This extreme variation implies the object is highly elongated. When its broadside faced us, it reflected maximum sunlight. Tumbling to its narrow end, it almost vanished. These proportions are unlike anything we've seen in our own system. Oumuamua belongs to a physical category of object that we are only just beginning to define. The mystery grew even more complex after Oumuamua passed its closest point to the sun. As it began to leave, it experienced a slight non-gravitational acceleration. It was picking up speed, pushed by a force beyond gravity. Ordinarily, we see this in comets. When near the sun, internal ice turns to gas, creating jets that act like natural rocket thrusters. This process creates a massive, visible tail of dust and vapor behind the object. But Oumuamua was different. Our most sensitive telescopes looked for a tail, a cloud of dust, or even trace amounts of carbon monoxide. They found nothing. It was accelerating with no visible outgassing whatsoever. It appeared to have an invisible source of thrust, behaving as if it were a comet while lacking the physical features that define one. To explain this invisible acceleration, astronomers proposed several new ideas. Perhaps it was a hydrogen-rich body, outgassing invisible elements, or a fragment of nitrogen ice chipped off an exoplanet in a distant solar system. Another possibility is that Oumuamua is a piece of planetary shrapnel, a fragment of a world that was torn apart during a violent collision before being ejected into the void. The lack of conventional explanations led Harvard astronomer Avi Loeb to suggest a radical idea, that the object could be an artificial light sail, designed by an advanced civilization to catch the radiation pressure of a star. Most astronomers favor the natural hypotheses, as we currently have no direct evidence of artificiality. There were no radio signals and no signs of a manufactured structure. Even so, requiring such a diverse range of theories to match the data highlights the limitations of our existing catalog of space objects. Oumuamua forced us to broaden our understanding of what can exist in the spaces between stars. For hundreds of millions of years, Oumuamua likely drifted through the freezing interstellar void, crossing light years in total silence. Its brush with our sun was only a momentary flicker in its long billion-year history. Its legacy is now part of the way we search the sky. We now know that these visitors are likely passing through all the time. In response, astronomers are building new, highly sensitive surveys designed to detect future interstellar objects while they are still far enough away to study in detail. We already have a point of comparison. In 2019, we discovered 2I Borisov. As this data table shows, Borisov looked and acted like a standard comet. It had a round core and a massive tail of gas. It was exactly what we expected to see. The fact that Borisov was so typical only makes Oumuamua look more unusual. It remains a singular event in the history of astronomy. Oumuamua is now a dark, silent object racing away from our solar system. It has passed the orbit of Neptune and is heading back into the deep space between stars, never to return. While current science leans toward a natural explanation, perhaps involving exotic ices we've yet to study up close, the object remains a mystery. Our window of observation was simply too narrow before it vanished into the dark. Some of the universe's greatest puzzles don't stay with us for long. They simply pass through, leaving behind questions that may take generations to answer. If you want to join us as we explore the greatest unsolved mysteries of space, astrophysics, and the cosmos, subscribe for more documentaries. Keep looking up.